Hello everybody and welcome to Trig 2. So today we're going to learn about arc length and circular motion. So let's just scroll down here. So remember what an arc length is. So for example, S right here is an arc length. Okay, so we want to find what is the length of that arc given by theta. So the formula we're going to use is S equals R theta. So S is your arc length, R is your radius, and theta is your degree. Key thing here, theta is always going to be in radians. We're never going to use degree for this formula. So you always need to check, am I in degrees or radians, and make sure that you're in radians. So we're going to go ahead and practice this. So it says, given a central angle of 60. So let's draw ourselves a picture. So I have this circle with a central angle. Remember, central angle means that it's coming from the center. And this is 60 degrees. And it tells me the radius of this is 8 centimeters. We want to find what is the length of the intercepted arc. So what is this arc length right here? Okay, so the first thing I pay attention to is 60 degrees is not in radians, that is in degrees. So what is 60 degrees equal to? This is one of the ones that you guys should just have memorized. So 60 degrees is pi over 3. So you guys should have your main ones memorized. So you should have 0, 30, 45, 60, 90. You should know those like the back of your hand. So again, 0 is 0, 30 is pi over 6, 45 degrees is pi over 4, 60 degrees is pi over 3, and then 90 degrees is pi over 2. So we're using pi over 3. So we're going to use the formula S equals R theta. So we're going to get S equals, my radius is 8, my theta is pi over 3, and then we're going to multiply this together. So we're going to get S equals 8 pi over 3 centimeters. And we're going to leave it just like that in terms of pi. All right, let's try our next one. So if a 100-degree arc of a circle has the length of 9 inches to the nearest inch, what's the radius of the circle? So now it's giving us our arc length. It's giving us our degree. We want to figure out what's my radius. Okay, so we have 100 degrees. We don't know what R is, and we know that this arc length is 9 inches. Okay, so the first thing, 100 degrees is not one of the ones that we just know off the top of our heads, but you guys should know how to convert them. So we're going to do 100 degrees times pi over 180. So remember, if you ever get confused, do I use 180 over pi or pi over 180? So you want your degrees to cancel out. So I have a degree here, I have a degree here. I want those to cancel out. So I need 1 in the numerator, 1 in the denominator, so they cancel. So then I'm just left with radians. So that's how you can always double check if you're using the correct conversion. So right off the bat, I'll take off 100, take off 10, take off 10. So I have 10 and 18. We know how to simplify 10 and 18. So this would give me 5 and 9. So when this simplifies, I'm going to get 5 times pi is 5 pi, and then 9 times 1 is just 9. So I get 5 pi over 9. So this is 5 pi over 9 in radians. Okay, so now we're going to plug into the formula S equals R theta. This time I know S, I don't know R. So S is 9, so we're going to plug in 9. R, don't know, leave it as R. Theta, 5 pi over 9. Okay, we want to get R by itself. So right now it's being multiplied by 5 pi over 9. So to undo it, we would multiply by its reciprocal. So its reciprocal would be 9 over 5 pi. So we're going to multiply both sides by 9 over 5 pi. Okay, so obviously these will simplify, so I'm just left with R. On this side, we're going to get 9 times 9 is 81 over 5 pi. And this is in inches. So my radius would be 81 over 5 pi inches. Again, if we wanted a decimal, you would just plug this into a calculator. 81 divided by 5 pi. Get your decimal. All right, let's try example 3. So find an angle in radians and then convert it to degrees. So we want to figure out what is my theta. So let's zoom in again. Okay, so we have to still use that same one. So S equals R theta. S equals R theta. I know what S is. S is my arc length. My arc length is 8. My radius is 5. My theta, I don't know. Okay, solve for theta. So I'm going to divide each side by 5, divide by 5. So we get theta is equal to 8/5. This is still in radians. Okay, because this formula is in radians. So this is in radians. Yes, normally we see radians have pi's, but they don't have to have a pi. Okay, pi is just a number, and this is just a number. So this is still a radian. 8/5 is a radian. So now we want to convert this into degrees. So we're in radians. So we have theta is going to equal 8/5. And then for degrees, I want degrees, so I'm going to put the degrees in the numerator, pi in the denominator. Now we're going to have to go ahead and use a calculator. So theta is approximately, and then we're going to plug this into a calculator. So we'll use this calculator. So we have 8 times 180, so we'll do 8 times 180. So I'm just multiplying my numerators. And then that's going to be divided by 5 pi. So I'm going to use parentheses. I'm going to use 5. And where is my pi button? So pi is right here. I think it's on the second. There it is. Okay, equals 91.673. So theta is approximately 91.673 degrees. And then it does tell us to round to the nearest whole degree. So theta is approximately 92 degrees. All right, so that was arc length. Now we're going to talk about linear velocity. So that's really talking about speed. So it says, have you ever thought about math while out for a bicycle ride? Probably not. You know how to find your average speed by calculating distance traveled divided by the time from how long. So it's rate equals distance divided by time. In trigonometry, we call this linear velocity or speed. And rename our variables using v for velocity, that's our rate, s for our arc length for distance. So this is the formula we're going to be using. So velocity is equal to my arc length divided by time, or my arc length is equal to my velocity times time. So let's look at this one. If you travel in a car at 65 miles per hour, how far do you go in 10 seconds? So ultimately what I want to figure out is how far do I go in 1 second? And once I figure out how far I go in my 1 second, then I just multiply that number by 10 to get how far I go in 10 seconds. Okay, so we're going 65 miles per hour. That's my velocity. That's my speed. So 65 miles per 1 hour. So that means in 1 hour, I'm going to go 65 miles. I want to know how far I go in a second. So we're going to multiply this. And we want the hours to cancel out. So that's why I have an hour here, an hour here. That's my goal. But we want seconds down here. So we have to ask ourselves, how many seconds are in 1 hour? Well, there's 60 seconds in a minute, and there's 60 minutes in an hour, so it's 60 times 60, which is 3,600. Okay, so now this allows us to cancel out hours. And then I'm going to end up getting 65 miles per 3,600 seconds. So 65 miles and 3,600 seconds. Okay, so to figure out, okay, how many miles do I go in 1 second, we're just going to divide it. So again, using a calculator, we're going to do 65 divided by 3600, which equals 0.018056. We'll just spread it out a little. So equals approximately 0.018056, and this is miles per second. Okay, so now I know how many miles per second I go. Now I can figure out how far I go and how far I'm going to go. So it's my arc length. So S is equal to velocity times time. So we're going to get S is equal to velocity is 0.018056 miles per second. And we're going for 10 seconds. Okay, so again, my seconds will cancel out, so I'm just going to be left with miles. When we multiply by 10, we just move our decimal over one place. So we're going to get it's approximately 0.1806 miles, or if you wanted to round it 3 decimal places, whatever. So that's approximately how far I would go. Okay, so that's linear velocity, and then we have angular velocity. So now let's look at another type of velocity while we ride our bike. Think about how fast the wheels are rotating. This is called angular speed or velocity. The Greek letter omega, it looks like that W, is the accepted variable used for angular speed. This is the rate that measures changes in the wheel's central angle theta over time. And then this is the formula we're using. So angular velocity is equal to whatever our central angle is divided by time, or our central angle is equal to our angular velocity times time. Okay, so if a central angle spins 15 pi radians in 8 seconds, how fast is the angle spinning per second? Round to the nearest thousandths. Okay, so we have angular velocity is equal to our theta divided by our time. So we get our theta is 15 pi. And again, let me just make a note. All of these formulas are in radians. Make sure that we're all in radians every single time, no degrees. So we're going to get 15 pi radians per 8 seconds. And then that's all we have to do. We're just going to type this into a calculator and get how many radians per second. So we're going to get, clear this out, 15 pi divided by 8. So we get 5.890. So we get 5.890 radians per second. All right, next page. So now we have a nice little summary of what we just learned. So we have linear velocity is the dimensions of length per unit of time. So let's highlight that. Length per unit of time. So, for example, feet per second, miles per hour, meters per minute. Where angular velocity is the dimensions of the angle measure in radians per time. So it's angle measure per time. So, for example, we have revolutions per minute, radians per second, degrees per hour. All right, so we're going to go ahead and convert these. So convert 60 revolutions per minute to radians per minute. And then we're going to convert that to degrees per second. Okay, so again, since we're talking about revolutions per minute, we're talking about an angular velocity, which is W is equal to theta divided by our time. Okay, so theta this time is 60, and this is going to be revolutions per 1 minute. And we want to change revolutions to radians. Okay, so we have to use a little bit of brain power here. So a revolution is a full time around a circle. So like when you guys see in your cars, like it has RPM, like revolutions per minute, that's like how many times your tire is making a full circle. Okay, so if we want to convert this, and we want to convert this to radians per minute, so I need radians in the numerator. So I need radians in the numerator. Well, what is the same as, what is 1 radian? So 1 radian is 1 time around a circle. And 1 time around a circle is 2 pi, a distance of 2 pi. Okay, over 1 revolution. So there's 2 pi radians in 1 revolution. So now we can use this and get what we want. So we're going to have revolutions are going to cancel with revolutions. Okay, and now I'm going to have radians per minute, which is what we want. So we get W is equal to, and then we're going to get 60 times 2, which is 120. We still have a pi, and then we have radians per minute. So hopefully that made a little bit of sense. Okay, so this one we need to change 2 things. So we need to change our revolutions to degrees, and we need to change our minutes to seconds. Okay, so we're going to get, again, 60 revolutions per minute. Let's go ahead and change our minutes first, because that's just kind of easier to handle. So 1 minute, right, because we want minutes to cancel. So how many seconds are in a minute? And you guys should know there's 60 seconds in a minute, so 60 seconds on bottom. So now I was able to eliminate minutes, and now I have seconds. So right now I have revolutions per second. Okay, but we want degrees per second. So now we want to cancel out our revolutions. So to cancel out our revolutions, we want revolutions in the bottom. 1 revolution. Again, 1 revolution is 1 time around a circle. Okay, and what is that? What is 1 time around a circle in degrees? Well, that's 360 degrees. So we're going to do 360 degrees. So now I have my revolutions to cancel. Okay, beautiful thing about this, keep simplifying. I have a 60 and a 60, those cancel. So I'm all canceled out. So I have 360. In the numerator, I have degrees. In the denominator, I have seconds. So it goes 360 degrees per second. So that means my whole tire, or whatever we're talking about, the whole thing is going to rotate a whole circle within 1 second. All right, so here's some important relationships. This is just summarizing everything that we've pretty much talked about. Don't really need to go over these. All right, so now we're going to talk about area of a sector. So this is like a piece of a pie, the area of a sector. So area of a sector is equal to 1/2 r squared times theta. Again, theta is in radians, never in degrees. It's always in radians. Okay, so theta, so we're looking for like a slice of a pie, the area of a piece of a circle. And we're going to draw a picture so we can see this. So it says, find the area of the sector of a circle with a radius of 2 feet formed by 50 degrees. Round your answer 2 decimal places. So I have a circle. Oh, I think my little thing has a circle drawer. Good enough. Okay, so I have this circle, and it tells us that my radius is 2 feet. Guess I could have drawn my circle a little bigger. And the angle formed is 50. So then this is 50 degrees. Yeah, let me draw this bigger because this is really tiny. All right, let's try this again. Okay, so I have a circle. The radius of this circle is 2 feet. And the angle of this is 50 degrees. And we're trying to find the area of this sector. So I'm trying to find this area of this piece of the pie. So that's what we're trying to do here. So area is equal to 1/2 our radius squared times theta. So again, first thing I need to be careful about, this is in degrees, I need it in radians. So 50 degrees would be pi times pi over 180. So that's going to go ahead, again, those will cancel, the degrees will cancel. So I get 5 pi over 18. So area equals 1/2, my radius is 2 squared, times 5 pi over 18. So I'm going to get 1/2. 2 squared is 4 times 5 pi over 18. Let's go ahead, simplify before I start multiplying stuff. This will cancel. I could do the 18 and the 2. That will give me a 9. So I get 5 pi over 9 feet. Area is always squared, so feet squared. And if we wanted to figure out what this decimal is or what we're approximately looking at, we can type that into our calculator. So we have 5 pi divided by 9, so 5 pi divided by 9, which is approximately 1.75 feet. 1.75 feet squared. All right. Finding the distance between two cities. So Memphis, Tennessee is located at 35 degrees and 9, what would that be called? 9 minutes? 35 degrees and 9 minutes north latitude of New Orleans. Louisiana is 29 and 57 minutes north latitude. Assuming that the radius of the earth is 3,960 miles, and the city lies along the same longitude, find the distance between the two cities. Okay, we need to draw a picture. So we're assuming they're lying along the same longitude. So if this was Earth, that would be my longitude. Okay, and then we have the equator. We'll just draw the equator because the equator is 0. So this would be my equator. And that radius to the outside of the circle would be 3,960 miles. Okay, so then we have New Orleans, like located right here. So this would be New Orleans. Okay, and then above New Orleans would be Memphis. Okay, so above New Orleans would be Memphis. Okay, and we're trying to figure out here the distance between these two cities. So the distance between these two cities. So I'm trying to find this distance right here. Okay, so in order for us to find that distance, we would need to find this angle measure. All right, so we know one of these, and if you guys notice, so from here to here is 35 degrees and 9 minutes, and from here to here would be 29 minutes and 29 degrees and 57 minutes. Okay, we want to find the difference between those. So ultimately, we're just subtracting those. So we want to find the difference between those two cities. So theta, so we're trying to find the angle between two cities, which is equal to our theta. Okay, so theta would be equal to the difference of those. So I would have 35 degrees, 9 minutes, minus 29 degrees and 57 minutes. You guys should know how to convert these back to just degrees. So 35, and then you divide the minutes by 60. So you would do 9 divided by 60. 9 divided by 60, which is 0.15. So this is 35.15 degrees minus 29. And then same thing, 57 divided by 60 would be 0.95 degrees. Subtract those from each other and we get theta is equal to, what, 5.2? 5.2 degrees. So this angle right here is 5.2 degrees. Okay, in order to run, because we're trying to find an arc length right now. So in order to run any sort of formula on any of these, we need these in terms of radians. So now I need to take my 5.2 degrees, change it to radians. So next step, I would do 5.2 degrees times pi over 180, which is approximately, and again, calculator. So we're going to have 5.2 times pi, not tangent, 5.2 times pi divided by 180, which equals 0.0908. So 0.0908 radians. I'm just going a little bit longer just so we have a more accurate answer. So now we're going to find arc length. So remember, arc length is equal to our radius times our theta. So we're going to get S is equal to 3,960 times our theta of 0.0908 radians. So S is approximately, so I still have that number in my calculator. I should. And so I'm going to multiply that number by 3,960, which is 359.398. So S is approximately 359.398, and we're talking about miles. So, in all, Memphis and New Orleans are about 360, we're just rounding, miles apart. So they're about 360 miles apart. All right, last two, I think. So area and distance, some earthly discoveries. So compute the length in feet of an angle measure of 1 minute on Earth, given that the radius of the Earth is 3,960 miles. All right, so we want to figure out what's 1 minute. So my degree is 1 minute. Okay, and we know as a degree, 1 minute is 1 over 60 degrees. Okay, because for minutes, we just divide by 60 to get our decimal. We're going to leave it like that. And then we want to change this to radians. So for radians, we do pi over 180 degrees. So then my degrees will cancel each other out. Nothing else will simplify here. So I get pi over, what's that? 108,000. So that's my radians. And now we want to find the length. So we're looking for an arc length. So again, for arc length, we're doing S equals R theta. So we're going to get S is equal to R is 3960 miles. My theta is pi over 1008. All right, let's go ahead, simplify where we can. Right off the bat, cancel out those zeros. What else could we do? I think 11 and 30. Let's see here. Just trying to see what this simplifies by. Try some numbers. $36. I think 36 goes into both of those. So 36 goes into this 11 times, and 36 goes into this. Oh, I have too many zeros. I messed up. Too many zeros. Take off a zero. There we go. Okay, now we cancel those zeros, and then this would be 30. So 36 went into both of those. And 11 and 30 can't simplify anymore, so we're going to get 11 pi over 30 miles. And if we wanted to get a calculation, that is approximately 1.1519 miles, putting it into a calculator. Okay, this question wants to know, what is it in feet? So now we need to convert this miles to feet. So we're going to take our 1.1519 times how many feet are in a mile? 5,280 feet in a mile. So multiply those together and we get approximately 6,082.032 feet. So it's approximately 6,082 feet. Okay, what is the length of an angle of 1 second on Earth? Go ahead, pause the video and see if you guys can do this by yourselves. You should be able to, because it's pretty similar to what we just did. Instead of a minute, a second. All right, so we have theta is equal to 1 second. We know 1 second is 3,600. 1 over 3,600 degrees. Times pi over 180 degrees. So again, our degrees cancel, so we can have radians. And we get pi over 648,000. Okay, so again, we're doing S equals R theta. So we're going to get S is equal to 3,960 miles times pi over this huge number, 648. Okay, simplify. These would cancel, those would cancel. Again, 36 is going to go into both of those numbers. So you guys should have got 11. And this one would have been 1,800. So we get S is equal to 11 pi over 1,800 miles. And this one doesn't say we have to do feet. So we're going to leave it like that. If you wanted to plug it into a calculator, it would have been 0.019199 miles. But I like exact answers because it's less work. And again, if we did want to do feet, it didn't tell us we had to do feet, but if we did do feet, you just take that decimal, multiply by 5,280, and we get approximately 101.37 feet. All right, and that's going to conclude our notes on trigonometry 2.